In this function, I'll be talking about linear functions, slope, and applications. So, we already learned how to plot points to graph linear functions, and we also use the intercepts, two special points, to graph linear functions. I had told you that there's an easier way, and in this lesson we'll talk about the slope-intercept method. But before we do that, we need to discuss slope. And a big part of college algebra is graphing. And so really we're laying a foundation for graphing as we look at linear functions. All very important skills. All right, so let's go ahead and get started. It says the slope of a line is a measure of its slant or steepness. The slope of a line can be defined as slope equals rise over run, or the change in y over the change in x. So it says find the slope of each of the following lines. Now, sometimes you'll be given points on lines, and so that makes it kind of easy for you. But honestly, that's something you ought to be able to do just by looking at the line. So as you look at this first problem here, you want to identify two what I call nice points. So we're looking for points where the lines intersect of our squares on our grid. So you can see, I forgot to do that. Let's write rise over run here. That's how we get slope. And so we need 2 points. So 0, 0 is certainly on the graph. And then also the point 2, 3. Now there's also a point down here, and you could have used any of the 2 points. So it really doesn't matter. The key is having 2 points. And then we're going to use rise over run. Now for me, I always like to go from left to right. It actually doesn't matter which point you start at. You'll get the same answer here. But I'm going to start with this point that's on the left. So we're going to rise. Well, notice we're going up 3 in the positive y direction, and so the y value is 3, or the rise is 3. And then we're going to run. Now we're moving in the x direction, the direction of the x-axis, and we're going 2 in the positive x direction, and so we say that the run is 2 and our slope is 3/2. Now I would encourage you to try to do the next 2. All right, so let's see how you did. So again, I'm going to write rise over run because I'm finding slope. I need to find 2 nice points. So 0, 4 is a nice one, and so is 1, 1. Now if you used, let's see, this is also 2, negative 2 is on there, and it looks like we have one more here. Again, you can use any of the 2. So our rise, again, I'm going to go from the leftmost point to the right. And the reason why is because when we read graphs, we do read them from left to right. And so we're going to go down 3. So notice I went down, and so that's negative y direction. So I'm using negative 3. And then I'm going 1 to the right. And that's positive direction, so that's a 1. And by the way, if you're always going from left to right, your run will always be positive. So it's nice to do things in a way that you're consistent to keep things simple when you're doing math. So that's one thing I like to do there. And so our slope would actually be written here as negative 3. All right. On the next one, I hope you just look at it and you know that it's undefined. But perhaps you didn't know that. So let's talk about this. And actually, before we do that, let me just finish out this problem. So here's 2 points, and you really could pick any 2 points. And I'm going to start at 3, 0. And so I would go up 1 and right 0. I wouldn't move to the right. And so that, oops, excuse me, I just hit the wrong button. Okay, so we know that we can't divide by 0 when we're working with fractions. That expression is undefined, and so notice we do get undefined. Our slope is undefined for a vertical line. So let's talk for just a minute about this. If I give you these 3 lines, whoops, let's see. there's something you can tell me about each one of them. From left to right, the first one goes up, so this is a positive slope. And the next one from left to right goes down, and so you know it's negative slope. We talked about the undefined case. And then finally, a line that's horizontal. So the undefined case, that's what we call a vertical line. The one that's horizontal has a slope of 0. So if you didn't know these two, I would encourage you to make sure you get to know them. These are all basic things that you need to understand about lines. All right, let's move on. On number 2, it says the slope of a vertical line. Well, we just talked about that. That's undefined, and has an equation of the form x equals k. The slope of a horizontal line is 0 and has an equation of the form y equals k. So basically, notice these are considered linear equations, but they only actually have one of the variables. If you have x equals a number, that's going to be a vertical line. If you have y equals a number, that's going to be a horizontal line. So let me show you how to graph these. So graph x equals -2. Well, x is equal to -2 at that point right there. But in fact, x is equal to -2 for any point on this vertical line. And so for that reason, when we graph x equals -2, it's going to be this vertical line. Now, what I find is students get things mixed up, and sometimes they go the opposite way and draw this line, which is incorrect. So to avoid that, if you ever have any doubt, you could always make an XY table, and any point on this line that you're going to draw should have an x value of -2. And since there is no y value in your equation, you can actually let y be anything. And if I actually graph these points, notice those 3 points are on my vertical line. All right, I would encourage you to do B and then check my answer. All right, so y is equal to 3 right there, and it's going to be the horizontal line that goes like that. And again, if you look on this line, all the y values are 3 because every point is up 3. And again, if you want to use the table to do this, you can let all your y values be 3. Again, when we plot points, we usually choose 3. And then our x values can be whatever we want. I'm picking them to be nice, 0, 1, and 2. So that's these points, and notice they are on the line. All right, let's move on to the next slide. Oh, I did want to mention, these are what we call the special cases. I don't know if you're like me. My mom always said I was a special case. These are special cases when it comes to lines. All right, let's move on to the next one. Okay, so on number 3, it says given 2 points on a line, we call them x sub 1, y sub 1, and x sub 2, y sub 2. The slope m of the line can be found using the slope formula. And so m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now I usually just say y2 minus y1 over x2 minus x1. Don't let these little subscripts bother you or trouble you. This is just the first point, and y1 is just the y value of the first point. This is the second point, or what I'm calling my second point, and x sub 2 is just the x value of the second point. That's all this means. Now I'm going to go back to what we already did on the first slide, and I just want to point this out. Notice it's y minus y over x minus x. Now remember with rise, that was this here, and that was the difference in the y values. If you actually subtract the y values of these 2 points, you get the 3, which is your rise. And for the run, that was the change in x, or x sub 2 minus x sub 1. You can get that using your points by just subtracting the x values of these 2 points. All right, so that's what's going on here. Let's go ahead and go back to where we were. Whoops, I went a little too far. All right, so in this first problem, it says use the slope formula to find the slope of the line passing through the given points. So I'll call the point -1, 5 my first point, and 1, -3 my second point. So I'm going to go ahead and write down the formula. And by the way, yes, you do need to know the formula. That's something you should know and have memorized. And so now it's just what I call a plug and chug situation here. So it'll be y sub 2, which is -3, minus y sub 1, which is 5, over x sub 2, which is 1, minus x sub 1, which is -1. And so -3 minus 5, that's -8. And 1 minus -1, be careful, you're subtracting a negative there. That'll become 1 plus 1, which is 2. And -8 divided 2 is -4. And so that's the slope. So that's how we find the slope if we're given 2 points on a line. All right, so I would encourage you to try B and then watch the video. All right, so again, I would write down my points. Now you don't have to do this. As you get more comfortable, you can find slope, and you don't have to be quite as careful and step by step. But the main thing is that you can find slope given 2 points. So you write down your formula, you plug in your numbers. Notice it's 4 minus 4, we're subtracting the y values, over -10 minus -3. And so we're going to get 0 over -7, and that's 0. So this is actually, if you plotted these 2 points, these lie on a horizontal line. I did want to mention one thing here. Basically, when you do, it really doesn't matter which point you start at, but if I start here and I do 4 minus 4, then I want to start at the same point and do -10 minus -3. So that's important that you start at the same point each time. All right, so here on number 4, it says, if a linear equation is solved for y, we can easily use the slope and y-intercept to graph the equation. In general, if m is the slope of a line and the y-intercept of the line is at 0, b, then y equals mx plus b is the slope-intercept form of the line. So this is our next equation that we've got to have memorized. It's called the slope-intercept form of a line. When you have a line in this equation, you know the slope and you know the y-intercept. And by the way, we could also write it in function form. So this is the easiest way to graph lines most of the time, using the slope-intercept form. So let's go ahead and look at the first one here. So I'm going to go ahead and write the equation right below the slope-intercept form of a line. And you can see that m, or the slope, is 1/2. And yes, we like to use m for slope. And then that b is 3. That tells us where the y-intercept is. So the y-intercept is going to be at 0, b, or in this case 0, 3. So now we're going to be able to graph this quite easily. We're going to start at the point 0, 3, and our slope is 1/2. So remember, slope is rise over run. So we're going to rise 1, and we're going to run +2, so 2 in the right direction, and that gets us to another point on the line, and then you can just draw the line that goes through those points. Now notice if I went up 1 again and right 2, I'm back on the line. So you could actually find several points this way. All right, so I would encourage you to try B and C and then check the video. All right, so let's see. On B, again, I'll start the same way, and I need to identify the slope. It's -3, and the intercept, the y-intercept, is going to be 0, 2. And now the thing is, actually, let's go ahead and plot the point 0, 2. But notice for slope, I need a rise and a run, but I don't have a run. I don't have a denominator here. But certainly we can write this over 1. Negative 3 over 1 is still negative 3. And so now we're good. We can go down 3 and write 1. And so there's my other point, and there's your line. And again, if you go down 1, write 3 again, you'll keep landing on the line. All right, let's go to letter C here. So I have a question for you here. True or false? Negative 3/4 is equal to negative 3 over 4 is equal to 3 over negative 4. The answer here is true. Now 3 divided by 4 is actually 0.75. So negative 3/4 is 0.75. If you divide negative 3 by 4, you get negative 0.75. And the same thing's true here. And so they are all equal. And my favorite one to use, just again to be consistent, is I use the negative in the numerator. Now, if that's taking you off your grid, then you may have to use this form. But either of them is fine, and I'll show you that they both work. All right, so we know our slope is negative 3 over 4, and our y-intercept is the point 0.05. And so we'll go to 0.5, and since our rise is negative 3, we go down 3. Our run is 4, we go 4 to the right. And so we end up here, and there's your line. Now, if I had gone up 3 and left 4, you can see that I would still be on the line. I would just be using 2 different points to find the line. All right, I'm going to go ahead and stop here, and then I'll do a second part for this video.